Hello viewers, so in this video we're going to look at these examples and more. So let's look at number one here. It says determine cos of 2 arcsine of x. Okay, determine the value of that in terms of x. So what you want to do first is you want to let any variable, introduce a new variable, maybe the first letter of your name, provided that it's not x. Okay, so I'll choose r. I'll say let r to be equal to this inverse function alone. Okay, I target the inverse function because that's where the complication is. If I can simplify that one, then I'm fine. Let it be arcsine of x. From this equation, what is the value of x? The value of x is sine r. That will be your value of x. Okay, sine of r will be the value x. Why? When you have sine of an angle and then your angle, let's say it's p, let it be equal to what? Let's make it to be equal to 0 0.5 1 over 2. Okay, this implies what? This implies that when you solve for p, you will say p is therefore arcsine of this value that is here, 1 over 2. So what you did here is we said let r to be arcsine of the x, and then x will therefore be sine of that one. We reverse this thing that you're doing here. Solving the problem from here, you want to draw your little sketch there, a right angled triangle with your angle as what? Your angle is now r. What is in front of the trigonometric ratio? Not the inverse, right? This one, when you write, after writing sine of something equals to x, you want to write that r here. This is your r angle. Now it turns out is equal to x over 1. So using this triangle and this ratio here, your x will come here, x, and your 1 will come there. And therefore, the other side is the square root of 1 squared minus x squared. Okay. From here, we can now proceed and solve our problem that was saying solve cos of 2 arcsine of x. Okay. And we say, therefore, cos of 2 arcsine of x is equal to what? Let's check. It's equal to, remember we said this one up there, we said arcsine of x is r. Okay, remember, you still remember we said arcsine of x is r here. We are going to use that r now, replace this arcsine with that r, and then solving the problem will be us solving this thing. We can now just write this is equal to cos of 2, this is your r, right? And then from here you do the double angle of cos. You have cos of 2r. This is, you can write it in three ways and they will all produce the same answer. The first way is you can write it as cos squared of r minus sine squared of r. The second way is you can write it as 2 cos squared of r minus 1. The other way is you can write it as 1 minus 2 sine squared of r. Okay, this is what you can do. We will just use 2 and confirm it. If it's, you can just use the first and the last. Okay, you can just use this one and this one. And this one as well, if you use it, we're gonna produce the same answer like I said. But let's just use only those two. So I know that this value equals to this value, and it's also equal to this value as well here. So I can just write equal sign there. You can proceed either way. From here you can proceed that way or this way. Okay, 1 minus 2 sine squared of r. I just want to show you that it will produce the same answer either way you choose. It's mathematics. At the end of the day, it must mess out. So with the first one, let's say this is our first way, this is our second way. With our first way, we will say this is going to be equal to what? Cos squared of r. You have cos r, you want to write it like this, the square there. Cos r is this thing, this square root here, over 1. So the answer is just the square root of 1 minus x squared over 1. Okay, even if I don't write it, it doesn't matter. So this is just that, and then we're going to write again minus sine squared of r. What is sine squared of r? Do you still remember that sine squared of sine of r? I mean, sine of r is x. You don't have to go back to the sketch, you still have that value there. Or you can go to the sketch if you want to, doesn't matter, and say sine of r is x over 1. Sine of r is x over 1, and therefore you will have x over 1 there, that is just x all squared, and that will be, writing the final answer will then be, here you have square root of x, square root of 1 minus x squared, I mean, you want to square it, you're going to be left with only the inside function, that is the 1 minus x squared, and here you have minus x squared as well, and therefore the final answer is 1 minus 2x squared. So the final answer is 1 minus 2x squared. Let's confirm it using the second way. Okay, this is equal to 1 minus 2. We are looking here now, 1 minus 2. What is sine r? We just discussed it. Sine r alone is just x. We can go to the sketch. If you go to the sketch, sine r is x over 1 is x, or if you use this that we used to sketch the sketch, we will find that is again sine r is again x. Okay, now knowing that, you have to come back here and square. Okay, and that will be, that is that. This is the value of what? This is the value of that. You have determined that value in terms of x without trigonometric ratios. Okay, let's look at the next one. This one here says determine the value of a cos of minus 1. A cos of minus 1. The same procedure is the inverse itself, inverse function itself, inverse trigonometric function. Let it be another variable. I'll again choose r because I'm reticule. You can choose the first letter of your alphabet. You can choose Y, you can choose K, it doesn't matter. So I'll say R, let it be equal to, let R to be equal to arc cos of minus 1. Okay, so that cos, similar to what we did with the first one, cos of R will therefore be minus 1. This one is negative. Now you have to know where cos is negative with this one. You can calculate, there are two ways. You can calculate the reference angle and get the same answer as the person who will draw the graph, the cos graph. If you know the cos graph, it looks like this. It starts from 1, goes to minus 1, goes up again like that for 2 pi, from 0 to 2 pi. There's 2 pi there from 0. Okay, now what matters is, what is the value? This is our r-axis, this one here. Our x-axis in this case is just our r-axis. Okay, let me just indicate there, that is our r-axis. What is the value of r? The question is, what is the value of r? That will make us to have a function value of cos to be at minus 1. This is minus 1, that is plus 1. At minus 1 here, if you check it nicely, it's at pi. It's at pi. Here is at pi over 2, 0. Cos of 90 is 0. Cos of 180 is nothing but minus 1. Okay, and that's how you solve r. R is now what? R is now pi. The value of r is pi. But what is the value of r? What is r? Do you still remember that we said our r is cos inverse? So our r is, I can replace our r with cos inverse of minus 1. And the value for that is just pi itself. And then you solve the problem like that. Let's solve this pi again using the the cast diagram and the special angles. From this step, we will say, okay, we have our sketch that looks like that. You can check how I make this sketch easy on this short video. Please visit that short video. It will show you how you produce this sketch. And, you have the values here as your 0, 2, and then you have your 1, square root of 3, and then you have your square root of 2, square root of 2, and then you have your square root of 3, and you have your square root of 3, 1, and then you have your 2, 0 there. Okay, let's see. What we want to do now is we want to calculate the reference angle first. The reference angle, let's say ref angle, is the arc cos of positive 1. Now, based on that, when do you get when do you get this value? When will you get this value? Arc cos of negative 1. Okay. Your lines here, each and every line here has the value 2, and these lines are your hypotenuse for each triangle that you would like to sketch here. And the angles, the smallest one is 0. The smallest one is 0 here on the x-axis. That follows that one is pi over 6 there. And then here you have what? You have pi over 4. And then here you have what? You have pi over 3, that is 60. And then here you have pi over 2. Now we want the value of this thing, arc cos of 1. This one we can write it as anything over anything, anything over anything. But based on this sketch, it has to be, because our hypotenuse, cos is the x values over the hypotenuse, right? Now the hypotenuse must be the same as the x value on that value of a reference angle that we are going to get. Okay, let's go and check what is that value. Our x value to be, we want our hypotenuse to be 2. It's always 2. That one we know, it's always 2. We put it as 2. So we want to have 2 here. On which one of these values do we have 2 as our x? It's only here when our angle is 0. So this means our reference angle is just 0 radians. Okay, from here we just say our cast diagram looks like this. Where will the cos of the value be negative? It will be negative in the second quadrant and the fourth quadrant. Okay, so we want to go there. What is the value here is pi. It's 0, 90 pi over 2 plus pi again. You have pi over 2 plus pi over 2 is just pi, not plus pi. It must be plus pi over 2. 2 times pi over 2, that's 2 times 90, that is 180. That's how you get to that pi. You know the value there is pi on the cast diagram. Knowing that the value there is pi, you want to say now your r is equals to pi plus the reference angle, that is 0. So you just write plus 0 here, or pi minus the reference angle to accommodate this one, because cos is also negative here on the second quadrant. So we just say the angle will just be, again, r will be pi plus or minus 0, and that is just pi, the pi that we produced from the previous way that we used to solve the very same problem. Okay, let's look at the next one. Our next question here says find the limit as t goes to 2 for t squared minus 4 over t cubed minus 8, right? The problem with this one is when we plug 2, we are going to get 8 here, and 8 minus 8 is 0. Okay, so we cannot just go ahead and plug 2. When we plug there, we're gonna have again, we're gonna have 4 minus 4 is 0, but it's in the numerator. That one you don't have a problem with. If it becomes 0 and this one becomes a value, any value apart from 0, we can work with that and say the limit will therefore be 0. Okay, but in this case it's 0 over 0 is indeterminate, so we have to try to simplify it and show them what is the limit of that value they want us to solve here. You have to use the factorization method and cancel out those that will cancel. So this will be equal to the limit st goes to 2 for what? For t plus 2 t minus 2. We have difference of 2 squares there, okay, on top. And at the bottom, what we have is we have a small bracket and a bigger bracket, okay. Now that's how you produce those vectors. You want to take on the first bracket, you want to take this value as it is. You want to say it was t cubed minus 2 cubed. That is the value, right? Okay, let me write it like this because this is the way I want to use it. Let me write this is t cubed like that and 2 cubed. This is this value here, the t cubed minus 8. You want to write it like that. You want to take this t alone, the sign and the 2. You want to put them here, t minus 2. And then you are done. After this, you're almost done. Your next step is to take t, square it, and then put the answer here. It will be t squared. Okay, and then our next step is to you want to write the sign that follows here. The sign that follows here must be different from that one. The opposite of that one is, now we have the opposite of minus. It will be plus here. You write plus, and then you say 2 times t. You have 2t, and then you have the last one squared. The last sign is always positive. This sign that is here is always positive. Okay, now you have to take 2 all squared. You have 4. This one will cancel that one, and then you have your answer as 2 plus 2. I'm no longer writing a limit as t goes to 0. Can you see? Because I'm replacing t. Because I'm replacing t with now the limit as t goes to 2. I'm replacing that here. Then I have 2 plus 2 on top over 2 squared plus 2 times 2 plus 4. And the final answer will be 4 over, this is 4 plus 4 plus 4. That is 12. And this is just 1 over 3. 4 goes once there and then it goes 3 times here. So this is just 1 over 3. Okay, I hope it makes sense. Let's look at the next problem. So this one here says find the limit as x goes to 1 from the negative side, from the left of 1, of the following function, that is 1 over absolute value of x minus 1 plus 1 over x minus 1. Okay, what you want to do first is you want to check this guy. Be careful of that guy, and he's the only one, and he's the only guy that will give us problem solving this. So we have to check when he is negative and when he wants to be positive. We want to say when he wants to be negative, when x minus 1 wants to be negative, when it wants to be something that is smaller than 0, we're going to write this limit as the limit of this function as x goes to 1 from the negative side. And now you're going to write a negative in front of this bracket. You're going to make these brackets and then write a negative in front, né? So that when it wants to be negative, we multiply it with a negative to let it be, to bring it back to be a positive number, a positive value. Okay, so we'll write this as we can write the negative with the 1 there on top, and then we have there x minus 1. We can write like this, plus 1 over x minus 1. When we approach this limit from the left of minus 1, if this value wants to become a negative number, when it wants to become a negative number, we put a negative sign to do away with that negative so that it remains positive. Negative and a negative will become positive. And this one, we just let it be as it is. But when this value x minus 1, when it wants to be greater than 0, we can just write this as the limit as x goes to 1 from the left of minus 1, of 1 I mean, of 1 over x minus 1 as it is. But now let's check the condition. Which one aligns to this limit here? Let's say we must go only from the left of minus 1 because this is a contradiction of that. Okay, so this one says, this one here, it says we must it's when our x is less than 1. It's when our x is less than 1. Number line, we have 1 there. The values that are less than 1 are that side, and the values that are greater than 1 are that side. The limit says we must only approach 1 from the left side. We must go to 1 from this side, and therefore we disregard this whole information, this whole piece of information. We don't look at it, we only focus here. This is what we are dealing with, okay? Now, this will become what? Equals to the limit as x goes to 1 from the left of what? Of this value that is just minus 1 plus 1 over x minus 1. And this is just 0. We have here minus 1 plus 1. And then they are over the same denominator. That's why we took this negative that was supposed to stay here. We took it to be on top to stay with minus 1. So that, you can clearly see we have a same denominator there. Having the same denominator, that is x minus 1, we can write it as a single denominator here and add the numerators. That is minus 1 plus 1. This is just the limit as x goes to 1 from the left of what? Of 0 over x minus 1. And this is just 0 over x minus 1 is just 0. The limit of 0 as x goes to 1 from the left is just 0. So the answer for this problem is just 0. The limit is just 0 when you approach from that side. And it will be different from when you approach from the other side, the positive side of my from or at 1. When you approach 1 from the positive side. Okay, let's look at the next problem. This problem here is looking for the value of c. What is the value of c, constant c, for the function f of x to be continuous on this interval? Meaning for all x values, the function must be continuous. We don't care. This is what we are looking for. This is what the problem is saying we must solve. At x equals to 2, at x equals to 2, somewhere here, we are going to sketch our vertical line. So this is a piecewise function. F of x is given by 3x plus c, and then it's again given by c squared minus 2x plus 4. At that value of 2, where you split the two functions, you sketch this one for this interval, and you sketch this one for this interval. Okay, you're going to go to that value that is 2 and just put something like this, a vertical line like that. Now you want to sketch a function of 3x plus c for x values that are less than 2. So you want to come to the left of this line. You want to sketch 3x, gradient of 3x plus a value of c that we don't know, but we know that c must be a value in the y-axis where this line touches. And for that function, we were supposed to open. What I'm saying is we were supposed to open, and now we will have that line that is 3x plus c, where the value here is c. But you want it to be continuous. The condition is here, you want the function to be continuous, okay? So we have to shade here and go to the left to sketch this function that is our quadratic. If c is a positive number, then we will have something like the concave. We will have a concave up function this side, maybe something like that, maybe like that, maybe going down below the x-axis and going up. Doesn't matter. What matters if c is positive, is a positive constant, we will have either of these three. But they must all come touch here. They must all come touch here for continuity, to so that the function, our function is continuous. Because if it doesn't come touch here, it touches somewhere else, maybe here, and then here we have to open, and here we have to open, and we have something of that nature maybe. That is discontinuity. We don't want that. We want it to be the very same value. We want to have the same value there at 2. Okay. Yes, the domain of this function, it will be continuous, because I mean it's just from negative infinity to 2, from 2 to the domain is fine. The domain has no restriction, it's fine, it's continuous because it exists at 2. But the function itself is going to be discontinuous at a value of 2, if we have a situation like this. So we want to avoid that. We want to solve C such that this function, this value will be up there, starting from there to the right, and then do whatever that it wants to the right. So how do we solve it? How do we solve this problem? We have to put at the value of x, that is 2. This function must be equal to this function, and then the function will be continuous. Remember, we said if this value here is 4, if it's 4, we want this function, this one, when x is 2, to be 4. And you also want this function that goes to the left to be the very same number 4. If that value is 4 there, I'm not saying the value there is 4, but I'm just making an example. If we go to the left, that line must be touched at 4, and as you go to the right, it must start at 4, the very same value 4, and go that way. And so we will say 3 x is 2 plus c must be equal to what? The same c that we are looking for, the very same c, when x is 2 squared minus 2, x is 2 again, plus 4. Okay, and then we solve for our c from here. What is that value of c? This is just the linear function there. Be careful. This is just the linear function 3x plus c there. You must equate it to c into the very same x value, 2 minus 2 times 2, the x value, and then we have here plus 4. And then what we have from here, we have 6 plus c is going to be, this is just 4. This is just 4. C, this one goes away. It's minus 4 there, plus 4, it's 0. So you have 6 as what? As 3c. You have 6 is equals to 4c minus c. And then you have your c as what? As 6 over 3. And that's the value of c must be now 2. Okay? Now the value there must be 2. The value there must be 2. You can check it and draw this function. You can check it and draw this function and that one on the same set of axes, by saying, okay, if we draw it, it will look something like this. The gradient of 3 is very steep, and then we have our 2 there. Since our c is 2 here, sorry about this, this has to be 2. So c is 2, c must be 2, the of the linear function must be 2. And then you can check it at the value 2. When x value here is 2, there on top you must have their intersection, the intersection of these two functions. Okay, so you have something like that, but now at 2 we must include and have the value of our c is 2, is positive. C is positive, then the quadratic function will have a concavity, that is a concave up. Maybe it will be something like this, maybe something like that. As long as it's a quadratic but with a concave up, then you are good to go. Okay, so your function will look something like that. Okay, so the value of c is 2. You choose option A. Number 10 here says determine the limit as x goes to pi from the left of ln of x, ln of sine x, I mean. Okay, ln of sine x. How will you do this? You will start first by saying, you can do it graphically and determine the limit, or you can just use the mathematics Graphically is also the mathematics, but we can just let you introduce a new variable to be sine x. Okay, we let it be sine x. We want to check what happens as x goes to pi. As x goes to pi here, what happens? U goes to 0. So u becomes 0 as x becomes pi. Okay, this is what happens. And it only, because they say from the left of pi, if you can check, I will have to do graphically now so that you can understand what's happening here. Here's the graph of psi. As you go to this value here, that is our pi, here is our 2 pi. Okay, as we go to this value from the left of it, from the left of pi, the function is positive, because what in front of the ln must be positive, and that's why they put this restriction for you here, that you must only go from the left of pi, because if you come from the right of pi, we're gonna have a problem. Sine function is negative, and we have a negative in front of the ln, it does not exist. Okay, so what we see is when x goes to pi from the left, when x goes to pi from the left, u becomes 0. This is what you notice, right? Now you can, this is the limit that I was given is the limit of what? Of a ln of u. That's what happens as u goes to 0. Unfortunately, it will only go to 0 from the positive side of it. It was positive, the sine function, our sine function, that is our u, it was positive, and it wants to become 0. You cannot come from the negative side because we have an undefined there. So it will only come from the positive side of that sine function, that is positive side of that u. So that is that. And then what is this function? The answer here is just negative infinity. Why is it negative infinity? Because the graph of ln is just a function that looks like that. As you go, this is your u-axis in this case. This is your u-axis. As you move towards 0 on your u-axis from the right of that u, but you move this way, as you move that way, you get negative infinity. It will never touch 0. It will go towards 0, but it will not touch it. Okay, you can never be 0, so you just approach 0 then, so that you go to negative infinity like that. Okay, and we've done both parts in the same setting. If I personally in exam, I wouldn't sketch the graphs, I will just do it this way and then I'm done, or I just sketch the graphs and then I'm done. But I'm using both ways so that you can choose which one you prefer, this method, or you want to sketch the graphs and see that if sine x, when you go to pi from the left becomes 0, from it is from the positive numbers, it wants to become 0, then ln x, ln of whatever that is, this number here that wants to become 0, it wants to become, as this number wants to become 0, ln wants to become negative infinity, and then you are done interpreting the question of multiple choice like that. Then you choose f, and you're out of there, you move to number 11. But in this case, you're not moving to number 11, we are moving to this interesting question. Alphabet A. Let f of x to be equal to that 3x plus cos x there. Okay, determine if it is even, odd, or neither. To test those properties, you want to test what is the value of f of minus x. Okay, that value will be what? It will be 3 minus x, you replace every x with minus x, plus cos of minus x. Okay, simplifying this, will have minus of 3x plus cos of x. Why? Because cos of a negative angle is the same as cos of the very same positive angle, the very same angle, but with a positive sign. Okay, on your sketch your cast diagram like this, and you want to measure a negative angle, you are going this way. Cos is positive in there, so it cannot be negative cos of that angle. Okay, again, if you draw your cos function, it's something like this. So on the positive x values, on the positive x values, what you see on your left, on your right, I mean, is what you see on your left. So cos of positive whatever value is the same as cos of negative, the very same value this side. Is an even function. It has a mirror here, a mirror image along the y-axis. And therefore, cos of positive, that's why cos of a positive angle and the cos of negative, the very same angle is the same as that. Okay. From here, we see that the function is neither odd or even. Why? Because if you take out a negative here, what we are trying to see what's happening. Take out a negative as a common factor. We have negative of 3x minus cos of x. This is clearly negative of something that is not f of x. This is not f of x. F of x is 3x plus cos of x. It's not 3x minus cos of x. So this function is neither both of them. It's neither even nor odd. Okay. Alphabet B says here, if f of x is given by the square root of 2x plus 5 and g of x is given by x squared minus 3, determine f compot g compot 2. You want to check what is this value and you want to check g compot f as well. Okay, let's start with the first one. F compot g compot, we want to write f compot g at the value 2. Okay, when x value is 2, that's the same thing. We are going to omit the x of f, replace it with this whole thing, x squared minus 3. As we omit this x of g, replace it with what? Replace it with the value 2. The value 2, okay, to answer this question. Let's just go ahead and say now f compot g compot 2. What is this value? This value is basically the square root of 2 x. You want to replace it with x squared minus 3. What is x squared minus 3? X squared minus 3 is, now we are replacing this x with 2, this x that is here with 2, and then we square that, we subtract 3, and then we close. So far we've just written the square root of 2x there, and then we still have to add plus 5 there. Okay, we add plus 5, and the final answer will be the square root of, you have 2, you have this one as 4, 4 minus 3, 4 minus 3 is just 1, so we have plus 5 there, and the final answer is just the square root of 7. Okay, the square root of 7 is the final answer. They also want us to look at g compot f. G compot f will be you writing g compot f of x. Okay, of x will be x squared minus 3. You want to write x squared minus 3, but replace x squared, replace the x with what is the value of f, the function that follows g. In this case, we're replacing this x with that function because g was following f. Okay, g came after f. In this case, f comes after g, and this is how we do it. Our x is now the square root of 2x plus 5. And the final answer is therefore the square goes away with the square root, 2x plus 5 minus 3. This is just 2x minus 2x plus 2, I mean 2x plus 2. And that is the final answer for g compot f of x. Let's look at the next one. The next one here says if f of x is given by ln of x plus 6, find the f inverse of x. Okay, now you want to replace f of x, this is equal sign here, sorry, you want to replace f of x with x, as you replace the x here with the f inverse and then solve from there. Ln of the f inverse of x. If you don't want to write this so many times, the f inverse of, you can just replace it with y, solve for y, and then after that you are done. So we can take e of both sides, take e of both sides to do away with this ln. I don't want that ln anymore because I want to isolate this guy here, our f inverse of x. So you just take e, and then we have f of the f inverse of x. We have the f inverse of x plus 6 to be equal to e to the power of x. E to the power of x will be, this e goes away with the ln, this thing there is this thing there. F inverse of x plus 6. Okay? Under the community tab here, you click there under the community tab, and then you can select the correct answer. If you select the wrong one, 13% of the people I see selected the incorrect answer here. And because the answer is saying what is the answer to ln of x squared, you just take 2 in front and the answer will be 2 ln x. Therefore the correct answer is this one, the second one. 79% of you guys got it, I see. And here I put negative infinity as the first answer because people has that a mentality of that ln x is negative infinity. The limit of ln of x as x goes to 0, that one is infinity, is negative infinity, yes, and we just discussed it in this video. The ln of 0 is undefined. The function of ln will never go at x equals to 0. Okay, I see 80% of the people got that one right. I don't know what 20% of people are thinking when they choose one. It's not correct, guys. Okay, if you choose it will return red if you choose the incorrect one. And again, what is the answer to ln of e? Ln of e is just 1. I'm doing these quizzes so that you can get used to solving such problems in exams. You know how to cancel the lns and the e's. I'm gonna post more. Okay, let's continue. And therefore the final answer for the f inverse of x is just e to the x minus 6, and that is your final answer. Okay, let's look at the next one. The last one is just a matter of English and understanding mathematics. Just put it like this here and solve it. Alphabet D says, suppose that a graph of a function f is given. They give you a function, but they don't give you, but they tell you that they give you. Suppose that it is given. Describe how the graph of the function y, this one, that you want to form this way from the function of f, can be obtained. You are basically going to just say these things, -3 and -3, that is outside, inwards. That's all they want from you. Say it inwards, write it here. You are shifting, replacing x with x minus 3. You are shifting the function f, shift f 3 units. To which side? To the right. Why to the right? With a minus sign here, you move 3 units, you move a function 3 units to the right. That's how it works. And then with a minus sign outside here, you move 3 units to the minus sign. That is 3 units downside. You shift again 3 units, shift F, 3 units, 3 units down. In the y-axis, the minus goes down, the plus goes up. In the x-axis, when you add to it, you intend to move it this way, you say +3, it goes this way. And when you want to subtract that and move it that way, it goes that way. Okay, that's how it works. So the final answer will be shift f 3 units to the right, and shift again f 3 units down. That will be the final answer. Thank you for watching this video. Please don't forget to subscribe, share this video with your friends, like it as well, and take care. Bye.